All right, chapter 7, area between curves. Let me refresh your memory on a problem that looks like this that you saw in like the 6th grade. I got a rectangle and I got a circle. That circle represents a hole that I cut out of the rectangle. And I want to find the area of the remainder of that rectangle. What do I have to do? Find the area of the rectangle and subtract off the area of the circle. That's right. So you probably already know how to find the area of this region right here. If you notice on this graph, we have 2 lines coming down. So that's like my A to B right here. I want to find this area that's enclosed by those 2 boundary lines and then also the 2 functions that are forming the top and the bottom of that. How would I do that? So you integrate this guy here? Yeah. Okay. That's right. So if you integrate this, you'll have this whole area right here. If I don't want this stuff underneath, then I can integrate this guy, which will give me this whole area right here, and then I can subtract the 2. So how could I write that? Is there a way I could express that using calculus? All right, if I call this one f of x and this one g of x, then what is it? We need a dx in here. Very good. And in actuality, I can simplify that. This is written as 2 separate integrals. Can I combine that and make it one? Yes. The integral from a to b of f of x minus g of x. And that's all dx. So all we are doing from going from here to here is remembering that property that if we have an integral with several terms, we can treat each one of those terms individually. So the integral of f of x winds up being here. The integral of g of x winds up being here. We have exactly the same thing. So this is what we're doing this chapter. Slightly different problem here. How could we find the area created by the curves on this one? This is different. Yeah, the difference on this one is we're not going from A to B like we did last time. There is no A to B. This time we're finding the area created by the curves. So what do we do?
We can find out where they intersect?
Yes. Find out where they intersect. How do you find out where 2 curves intersect? Set the equations equal to each other. That will give me where the 2 graphs cross. All I need is the x-coordinates for that. But once I have those x-coordinates, that becomes my A, and that becomes my B. And then I'm finding the whole area that's involved here. So what would my integral look like there? If this is f of x, and this is g of x. Now it's the same thing, yeah. But the trick was you had to find a and b before you could do that. So it's the integral from a to b of f of x minus g of x dx. And how about this one? Find all the intersections. So we have one here, and one here. How do I find those intersections? Again, set the equations equal to each other. And when you solve, you will wind up with 3 solutions. And then how would I find the integral then? So let's say that we find this one, and we call that A. What would this one be? Okay. And what would this one be? Okay. Hold on. Before you do that, I got to call these functions something. What do you want to call them? F and G, which one's F? The double loop you want to call F? So I'll call this one f of x, that's fine. which makes this one g of x.
Okay, so the first one, from A to B, we'll take f of x minus g of x.
Why?
Because f of x is on top.
Okay.
Now we B to C.
Plus? Why plus? Right. Think of these as areas. We're taking this area and adding it to this area. So we're going to write plus what? G of x minus f of x. Why was it reversed this time? That's right. It's the top function minus the bottom function. The upper minus the lower. So here are your rules that you guys have already told me that you understand fully. For finding the area of a region between two curves. By the way, that's what we're doing. We're finding the area of a region between two curves. If the curves do not intersect, so that means I have a situation maybe like this. The curves don't intersect. They are curves.
It could be a curve.
And g of x is less than or equal to f of x over the entire interval. So what that's saying is g of x on the graph as you look at it is lower than f of x. Then determine which function is greater over the interval. Well, I just did that. The area is determined by the integral from a to b. So maybe that's a and that's b of f of x minus g of x dx. You guys already know that. If the region is formed by the intersection of two curves, so if I'm looking at something that does this, then find the intersection points by setting the functions equal to each other. We're looking for those 2 points. There's my a. Bring it down to the x-axis, a and b. A is the x-coordinate of the lower intersection, not lower as in lower in elevation on the graph, but lower as in to the left. B is the greater than the area is determined by basically the exact same equation. If the region formed involves two curves, or curves intersecting at more than 2 points, so I have a situation like this, then do exactly the same things we did up here, find all the intersection points. Set up separate integrals for each region, this region, and this region, and then add the two together.
Straw smile. Yeah, there you go.
So let's find the area of the region bounded by these graphs. The graph of y equals x squared plus 2, and the graph of y equals negative x. And then this is going to be important here. You're always going to have boundaries that are given to you, or they're going to say just the two curves when they intersect. So these two curves don't intersect, which is why we're given boundaries right here. Even if they did intersect and they gave us boundaries, the boundaries would kind of take precedent over the intersection points. So we're going from 0 to 1, and we have a lower function and an upper function. So because this one's the upper function, I'm going to call this one in my notation f of x. Look at me writing right-handed. And then this one is g of x. It's almost better than normal. But it was right-handed and backwards. I had to do it like this. I can write left-handed backwards too.
Just trying to go through 10.
Okay, so what do I need to do? And they're upside down.
Since we already have our points,
We can just integrate. Integral from 0 to 1 of the upper, which is x squared plus 2, minus the lower, which is negative x dx. Look at all those parentheses in there. Now what can we do?
combine like terms.
Yes, combine like terms. So we have the integral from 0 to 1 of
X squared plus x plus 2.
Good. Now integrate it.
1/3 x cubed
Okay.
plus 1/2 x squared
Okay.
plus 2x
Okay.
evaluated from 0 to 1.
Okay?
Do that.
You got to remember how to do this.
0 just turns everything to 0.
0 will turn everything into 0. So we go upper minus lower. So we have the upper that's going to do some stuff, but then minus a bunch of zeros. So that doesn't do anything for me. So I'm going to have 1/3 plus 1/2 plus 2 minus a bunch of zeros. So that just goes away. 1/3 plus 1/2 plus 2. Turn everything into 6. So this is 2, 6, plus 3, 6,
5, 6,
plus,
12, 6.
so we have 17 sixths. That would be the area formed by this region right here. So on a problem like this, find the area of the region bounded by the graphs of, notice the notation, or the language here, the graphs of. What do we have to do? Set the two functions equal to each other to find the actual intersection points. A couple of things I want to say here. First of all, if you're given a graph, you cannot assume anything. It looks like maybe -2, -2, and maybe +1, +1, but we can't say that for sure. So you actually do want to go through the math and find out the actual intersection points. So we take f and set it equal to g. 2 minus x squared equals x. Get everything on one side, right? Hopefully that's your next move. So I'm going to add x squared to both sides and then subtract 2 from both sides. And that gives me x squared plus x minus 2 equals 0. Now what? We don't have a product yet to do the zero product property with. You can factor it though. Two numbers that multiply to give me -2 but add to give me +1. Sounds good. Now we can use the zero product property and solve, and we get x equals 1, x equals -2. So now we have verified that what we expected here and here is actually the case. -2 and +1. Now what? Now you integrate, yeah. Integral from what to what? Yep. F minus g. And the reason we're doing f minus g is because this one is definitely the top function, and this one is definitely the bottom function. You have to go the top one minus the bottom one. So 2 minus x squared minus x dx. Now what? I would simplify first. Integral from -2 to +1 of -x squared, I hear that whispered, minus x plus 2 dx. So now I can integrate.
The most crucial part, I forgot to do that.
What? You didn't integrate?
I just went ahead and evaluated after that.
No, that's not going to work.
Oh.
-x to the third over 3 minus x squared over 2 plus 2x. And we're going from -2 to +1. So, what do we do?
This is where I
Plug 1 in. And we have -1/3 minus 1/2 plus 2.
minus.
Now we plug -2 in. -2 to the third power is -8, but it's a negative out front. That makes it positive 8/3.
No.
We have the -2 squared is +4, but that's a minus sign out front, so it's actually -2. And then we have -2 times 2 minus 4. My advice to you would be to simplify this down. Sixths. So this would be -2/6. So I got -5/6 now. So 7, 6. 7, 6. Minus 16, 6.
Minus 26.
See, I did the first part of it, but I
4,
forgot
6.
the second part.
And 4, 6 minus 24, 6. So negative 26.
4, 6 minus
24, 6.
24, 6 is negative 26.
But then
That's minus minus, which turns positive. So that all gives me 27, 6, which reduces to 9 halves.
Wow.
There's your answer. So just a quick refresher, because of the fact that we're working with direct or definite integrals, we can actually type that into our calculator. Let me move this over. Now the thing of it is you still have to set up the proper integral. So once we get the proper integral written down, then we can go ahead and do that integration. So we go to menu, calculus, and what am I finding? What am I looking for here? Numerical integral, thank you. And then I'm going from negative 2 to positive 1. And then my function, I can use either this one here before I simplify it or this one here after I simplify it. Either way is fine. So I'm using the one after I simplify it for no particular reason. So I hit enter and it gives me 4.5, which of course we know is 9 halves as a fraction. So as long as you have a calculator and you're able to use a calculator, you can do this. However, if you're not allowed to use a calculator, which by the way, most of the problems like this on the AP exam are going to be without a calculator, then you need to know how to be able to do something like this and go from here down to here, okay? So just be cautious with over-reliance on the calculator. Make sure you do get the practice you need with the actual by-hand algebra. Okay, a good point. The sine and cosine curves intersect infinitely many times, bounding regions of equal areas, as shown. Find the area of one of these regions. So which region do you want to find? This one? Okay. That's our region right there. Now what? When you set them equal to each other,
there's going to be an intersection point.
there are intersection points, and we do need to find them. There's one here, and also one there, obviously. So if I draw a dotted line up and down, we can't assume. We do have to find them, but we can kind of see where they're at, right? Okay. Normally you're not going to be given a graph, so you won't be able to even look at the graph to find them. You could graph them, but you still need exact limits. So, what's our process? Set them equal to each other. So I have sine x equals cosine x. Now what? So you want to set it equal to 0, but I don't know why you want to do that.
Divide by cosine.
There's two ways you can go about this. One is you can kind of think about where this x value must be true. Where is sine exactly equal to cosine? Pi over 4 and 5 pi over 4?
Yeah.
Okay. The other thing you could do is remember that tangent is another trig function you can use. If I divide both sides by cosine x, then I have tangent x equals 1. And now I'm trying to find where the tangent of something is equal to 1. And that's still pi over 4 and 5 pi over 4. So x equals pi over 4 and 5 pi over 4. Now what?
Now integrate.
So what do I write?
The integral from pi over 4 to 5 pi over 4.
Yeah?
Sine minus cosine.
Okay.
When we do it,
That it?
Now we have to evaluate it.
Okay, from pi over 4 to 5 pi over 4. Good, now what?
Now we need to find negative cosine pi over 4.
Okay, negative cosine 5 pi over 4 minus sine 5 pi over 4 minus negative cosine pi over 4 minus sine pi over 4. Positive square root 2 over 2 sine pi over 4. Is it?
The sine of 5 pi over 4, yeah.
Okay.
So negative,
Positive.
Plus. Okay.
so that's just,
We'll leave that alone for now.
negative cosine pi over 4, cosine pi over 4 is positive square root 2 over 2, so negative square root 2.
Negative square root 2 over 2.
Minus the same thing. So minus square root 2.
Okay.
We simplify those, we get square root 2 minus square root 2.
Square root 2 for this, because we get 2 root 2 over 2, so that reduces down to the square root of 2, reduces. And then minus, in parentheses, negative 2 root 2 over 2, which reduces down to negative root 2, minus minus would be plus, so my answer is 2 root 2. Okay, one more example like this. This will cover all three of the ways that we saw earlier on how you can find integrals. Either you're given bounds, or you have to find the intersections, or you have to find several intersections. So, that's the case on this one. What do we do? Okay, set them equal to each other. So I have okay.
Now combine like yeah.
I mean, get all your terms on one side.
Yeah. Sorry.
So we are going to add x squared and subtract 2x from both sides. Plus x squared minus 2x. And we get factor out the GCF, which is 3x times x squared minus 4 equals 0. That is a difference of squares there, so you could factor that. I'm not going to, though. 3x equals 0. X squared minus 4 equals 0. X equals 0. If I add 4 to both sides, I have x squared equals 4, and now I can just square root property this. X equals plus or minus 2. And if we look at the graph over here, it does seem like we have those three as our x coordinates for our roots. Now we integrate. So what do I write? Why?
Because that's the first section.
Okay, negative 2 to 0. Now what?
The top function,
Well, what's the top function? It is the cubic one. If you look at the graph, and this is where it's tricky because in all of the examples I've been giving you the graph, you have to figure those out on your own, on your homework and on tests and things like that. So use your calculator or plug in some values or whatever, okay? You have some intervals here from negative 2 to 0. Just plug in a negative 1 or something into both and find out which one's higher if you don't have a graph available, okay? So this one is F, and this one is G. Write what? Be careful with your parentheses. Make sure that you are taking the top whole function minus the whole bottom function. Then you can worry about combining your terms and things like that afterwards. But I would set this up. AP is going to be looking for this if they ask you to do a problem like this. Then what? Plus? Yes, now this one is on top and F is on the bottom, so it's going to be negative x squared plus 2x minus g of x, or sorry, f of x, which is 3x to the third minus x squared minus 10x dx. So now we integrate this by hand. What should we do? Combine all your like terms. So we have the integral from negative 2 to 0 of what? 3x to the third. Yeah, the negative x squared, this turns into a plus x squared, so that term disappears. And then I have negative 10x minus 2x, which is negative 12x dx, plus integral 0 to 2. Standard form? Negative 3x to the third. Negative x squared minus negative x squared disappears, and I have plus 12x dx. Do these by hand more than you do them on the calculator. You'll start to see things develop, and you'll understand how the math winds up working. If you just type stuff in a calculator, you'll never figure that out. Integrate. So we get okay. Minus 12x squared over 2, which would be minus 6x squared. That's going from negative 2 to 0. And then yep. Okay, and that's going from 0 to 2. Oh, you did that in your head? If I plug the 0 in here, both of these terms go away, so I'm left with the minus because it's 0 minus. And then the negative 2 to the fourth is 16, positive 16. But then divided by 4, that turns into 4 times 3 is 12. Then negative 2 squared is positive 4 times 6 is 24, so that's minus 24. So I have 12 minus 24, which is negative 12, but it's negative negative 12, which is 12. Plus from this. We only need the front half because of the 0. So we take the 2 and plug it in. Negative 12. Plus or minus 24? Plus 24. That becomes 12. 12 plus 12, the answer is 24 units squared. And you're done.